let us study about performing deletion operations in double linked list at 3 locations, at the beginning, at the end and at given location. In the first one, how do we delete an element at the beginning? Okay. Let us revise how we delete an element at the beginning of a single linked list first. Let us go and study that. So, in single linked list, if this is the case, if I have some elements like this, we know head will be always pointing to the first node and this will be null, it is linked this way. Okay. Now, I want to delete this element 10. I want to delete this element 10. How do I delete this 10? We were trying to take a temporary pointer, make this as temp, then we will make this temps next. What is temps next? This one. Okay. So, we will make a head equal to temp next. Okay. Temp next. So, this becomes your temporary, this becomes your head, right, this becomes your head. Now, this is erased. We are just writing one statement, we are taking this as a temporary variable, pointing it to the head, then you are writing a new address for head, head equal to temp next, that is this block becomes your head. That is it, your head is here, you want to delete this, just write free of temp. By that we are deleting this element from the list and we are having only a list like this 20, 30 and 40. This is the logic how we delete an element in the beginning of a single linked list. Now, let us try to analyze the logic of deleting an element at the beginning of a double linked list. So, what I am trying to do here, see this is our first node, we all know that it will be null here, right, this is my head. Same thing also we do here, we try to take a temporary pointer temp, let it point to head. Once you take a temporary pointer temp which is pointing to head, then temps next means this one, temps next is this one. Why it is pointing here? No, so this one. So, make temp next as your head. So, just write new, just write head equal to temp next, that is it. So, temps next means this becomes your head now. Next, what I have to do, when this becomes my head, I have to erase this, no, this should be null because it should not be pointing to this node, this location should not be pointing to this node, I have to make this as null, right. So, you write here head previous equal to null. Why? This has become your head already, its previous is already, it is pointing to some location here, that you make it null with this, 2 steps over. Now, this it means with this what happened, this link has broken, this link has broken, right. Now, you free this, now you free this. Okay. How to do that? How you free this? Free of temp, okay, free of temp, right. So, with this we will be able to delete an element from the beginning of a double linked list. If you see the logic again, take a temporary pointer, that let this be temporary pointer, this first element, its next this one, make this as your head and make this as null, that is it, job is done. When you make this null, these connections are broken, when this is made as null, these connections are broken, and then you use free function to delete that memory allocated for that particular node using malloc function. We are allocating memory using malloc, we will try to delete that using this temp free function, we will try to delete this. This is how we try to delete an element from the beginning of a double linked list. Okay, right. I hope it is clear. So, the code logic is very simple. What you have to do, you have to call a function, in that function you will write here delete at begin, you will have a function like this, you will pass the head as the value. In that what you have to do, just if the head is null, different story, if the head itself is null, say list is empty, there is no element, or otherwise if the list is not empty, then in that case you have to tell that what we can be done here, head equal to, simply write like this, temp of next. Here you have to create a temporary variable, temp equal to head. Okay. So, this is pointing here, its next, you are making this as your head. Next statement, heads previous, heads previous you have to make it null. This means this I have to make it null, and then I have to free the temporary pointer. I have to free this temporary pointer. This is the logic of deleting an element at the beginning of a double linked list. Any queries in this? Is it clear how are we deleting an element at the beginning? Once you understand it is almost same as your single linked list deletion. Right. Next one, double linked list deletion at the end. Okay, this is very important. This is little tricky to do. It requires a modification of multiple pointers. Okay, let's try to understand how we delete an element at the end of a single linked list first. Okay, how we delete an element at the end of a single linked list. I will say some free space. Yeah, here. So if there is a single linked list like this, this is null, this is your head, it has elements 10, 20, 30 and 40. It may point in this direction. The goal here is delete at the end. This node I have to delete. For that, what I have to do? We have to traverse the entire list. We have to traverse the entire list. How many pointers we need? We need 2 pointers, because you need to have track of its previous node also. This node which I want to delete and its previous node also I should keep track. That is why we need 2 pointers. Okay. So let them be P and Q. Initially this will be your P. P will be pointing here. Check if P's next is null, no. Then write P equal to P next. So this becomes your new P, and make this as your Q. Make this as your Q. Then again check if P's next is equal to null. Is it null? No. Make this as your Q and make this as your P. Again check if this box is null, that is P's next. Is it equal to null? Like this you verify. If this is null, if this is not null, then make this as your Q and make this as your P. Now check if P's next is equal to null. Yes, stop there. Where is your final Q? Here. Where is your final P? Here. Now what we are trying to do? Just single statement. Q's next means this block. Q's next, make it null. Q's next, make it null. That's it. This chain is broken now. This link is gone. And write free of temp, free of P. Right? Free of P. It means you are deleting this completely from the memory. So your list becomes very small like this. Okay. So this way we try to delete an element at the end of a single linked list. Now how to delete an element at the end of a double linked list? Okay, almost same approach, little tricky, because we are having two, right, one next and one previous. So we have to be little cautious here. Okay, let us see how it is done, right. So see, you want to delete this element, you want to delete this element. Same, iterate over the entire list. Okay, maintain 2 pointers, take 2 pointers. Let me explain the diagram here. You have a double linked list. Like this. So this is your head, and we have 2 chains. This is my null. Let the elements be 10, 20, 30, 40 and 50. This also will be null. Now what is the question here? We want to delete an element at the end of the list. So what I have to do? I have to traverse and reach the end of the list. I have to traverse and reach the end of the list. For that I will make this as my P first. Okay, I will make this as my P. Now how I do that? I will simply write like this, P equal to head. That's it. So this becomes my temporary pointer P. Now check if P's next is null. Is this null? No. Then make this as your Q and make write Q equal to P and write P equal to P next. P equal to P next. So in this case this will be erased now. Now this will become my new P. Again check if P's next is null. It is not null. Make this as your Q and make this as your new P. So these two will be erased now. next check if P is next is null. This process I will continue and I will reach, this will become my Q and this will become my P. By repeating this procedure, you will be reaching to the end of the list. Once you reach the end of the list, now what you have to do, what all operations I have to do, I have to make this as null first. I have to make this as null. So, what is this element Q? So, Q's next will be null. Q's next will be null. Okay, this has been made null. So, this link is broken. This link is broken, right? That is it. Once I break this chain, how to delete this? This one to delete, P's previous should be null. P's previous should be also null. Then this is also broken and we got null here. That is it. That free of this, you do free of this, we complete our deletion operation. Okay, we deleted the element at the end of the list and we made this as our null. Remaining all remain same, there is no change. Okay, so only logic is you have to maintain two pointers P and Q. We have already seen this kind of implementation in single linked list operations. Okay, let us try to understand with this example here. See, I am having this is the previous, this is my tail node, that is my Q, this is my P node, and previous node to tail, that is my Q node. This is my Q node, right? While traversing, maintain the previous node address also. By the time we reach the end of the list, we will have two pointers pointing to null, right? So, this one and this one. Next, update tail nodes previous nodes to null. This you make it null. Tail nodes previous node, next pointer means this one you make it null. That is it, this link is broken here, right? Then you free this, okay. Same step, this is your Q, this is your P, just make Q's next equal to null. When you write this, this box becomes null. So, the chains are broken here, there is no connection, and you free this, you just free the free the P variable, that is this is P, that is it. Same thing, we delete the element at the end of the list. Let us see the third one and the important one, how we delete an element at any given location of a double linked list. Okay. Before that, we will, like we are learning in this process, we will try to go and see how we try to delete in a single linked list first. So, this is my single linked list. This is my head pointer. This is null. I have elements 10, 20, 30, 40 and 50. Okay. Let the positions be 1, 2, 3, 4, 5. So, let this be 1, 2, 3, 4, 5. We are talking about deleting an element at any given location of a single linked list. Let the position be given as 3. So, you want to delete this particular node you want to delete. How do we delete this 3? What we have to do? We have to maintain again two pointers. Again we have to maintain two pointers. Initially I will make this as P. Okay, I will check the condition. What is the condition? I is less than position minus 1. Till that I have to iterate. If 3 is given means I have to reach till here. So, this becomes my P. This becomes my P. Okay. One pointer is enough, I guess. This is my P. Now, what I have to do? Now, let us talk in terms of number. Where is P pointing to? I will write P equal to. P is pointing to 20. P is pointing to 20. P's next is pointing to P's next. Right? P next. This is pointing, this P next is pointing to 30. Okay. P next, its next is pointing to 40. Okay. P is pointing to 20, P next is pointing to 30, P next is pointing to 40. Okay. This is about single linked list. How we delete an element at a given position in a single linked list. What we try to do? Simply one change. We will only break the change. we will try to create a link between these two like this. How? Write p is next, okay, p is next, that is this box is equal to p is next, this is equal to p is next, that is 40, p is next, its next. This one command will delete, form this link. Okay, it means this is broken now, this chain is broken now, because we have created this link. You just write free of p next. When you do that, it is deleted. Okay, this is the procedure how it happens for deleting a node in a single linked list at any given location. Okay, so let us go and see how the deletion happens for double linked list at a given location. Right, same thing here. See, I have to maintain two pointers, one is q, other one is p. I have to reach that position, that is p. Why I need this? Because I want to delete this. Okay, so in terms, let us say q is pointing to 15, p is pointing to 7. So what change you have to do here? This is your q, this is your p. Okay, then p next, let that be pn. I will call it as pn. P next is pointing to 40. Let this be pn. What is my logic here now? Q's next should be pointing to pn. It should be pointing to 40. Q's next should be pointing to this one. Okay, that is p next. Then p next previous should be pointing to q. P next previous is this. It should be pointing to q. That's it. This chain is created and we delete this node. Okay, this chain is created and we delete this node. Right. So this is the procedure of deleting an element at the end, beginning and at any given position. Right. For any given position, we have to maintain two pointers p and q. This is for deleting and this is to track and attach it to the next node like this. Okay. So this is the procedure of deleting a double linked list at any given position.